Hello and welcome to this lab demonstration on monitoring network performance. At the beginning of this lab, we already need to be familiar with the concept of VMware vSphere networking and ESX Top utility. In this lab, we will prepare our test client and server VMs to monitor network performance. Then we are going to measure network activity on an ESXi physical network interface. After that, we will use traffic shaping to simulate a network congestion. During our next task, we will position the client and the server VMs on the same port group and restart the test. And finally, we are going to stop the test and analyze our results. I'm sure I provided you enough good reasons to watch the following video on monitoring network performance, so let's get started. At first, what we need to do, we need to connect to our ESXi4 host. Let's do it using multi-putty, which we can find in our tray environment. Let's click on our ESXi4 and let's run ESX Top utility on this host. Now we need to change the display information for our networking statistics, but at first let's change the default refresh interval to 10 seconds from 5 seconds. For doing that, we need to type the S letter and set the delay to 10. And now let's type the N letter, which stands for networking. N. And now we can see some networking statistics for our ESXi host 04. Let's filter it a bit. Let's type the F button and let's drop 2 columns from the output. We do not need the information about packets received and packets transmitted. So let's drop the G letter from here and J letter from here, and let's type enter. Let's press enter. So now we can see the only statistics we need during this particular test. We are going to monitor the megabits transmitted per second value and the megabits received per second value during our tests. Now let's return to our vSphere client. And now what we are gonna do, we are going to launch 2 VMs, Linux 01 and Linux 02. One VM will become our some kind of a server application, and other VM will become some kind of a client application. So before we start with those applications, we need to go to our hosts and clusters, and we need to reconnect our Linux 02 VM to a different port group. Currently, our Linux 02 VM is connected to a PGSA production port group, and we need to migrate it to a different port group, to a different DVS. We are going to connect it to another port group, which is called PGSA management. For doing that, we need to go to a menu, networking. We need to find our PGSA productions port group where both of our VMs are currently located. We need to right click on the PGSA production and need to choose the migrate VMs to another network option here. Our source network of that migration is PGSA production, and our destination network, we need to set it. Let's click on browse. Let's choose our PGSA management port group on a different DVS SA data center. Let's click OK. Now we need to select a VM which we want to reconnect. This is gonna be Linux 02 VM. Let's click on next. So we are going to migrate only one VM from a PGSA production to a PGSA management port group on a different DVS. Let's click on finish. Now let's verify that this procedure has been completed. Let's go back to our hosts and clusters. Let's click on our Linux 02 VM, and now we can see that currently it's connected to a PGSA management port group. So what we are going to do next, let's begin with our Linux 01 VM. let's see that currently this virtual machine has received an IP address which is 172.20.11.200. We may also record this value. We are going to use it a bit later during this lab. Let's launch our Linux 02 VM. Let's power it on. We need to wait for about 20 or 30 seconds for this VM to successfully load. What do we need right now? We need to wait for this VM to load up, and we need to record its IP address. So again, our Linux 01 VM has an IP address which ends with 11.200. And for our Linux 02 VM, as long as we are waiting for Linux 02 VM, let's go to our Linux 01 VM. Let's launch its web console. Let's verify the IP address by typing ifconfig. So yes, this IP address is 172.20.11.200. And what about our Linux 02 VM? Let's open its web console. Let's log in as root and type a password. Let's type ifconfig to verify the IP address. And now we can see that its IP address is 172.20.10.200 with a network mask /24. So our VMs are located in different networks. What are we going to do next? We need to launch our pre-configured server and client applications on our VMs. So what we are going to do right now, we are going to begin with our Linux 02 VM. In its CLI, we need to change the directory to netperf directory. And now we are going to launch a pre-configured script for network performance test server. We need to type ./netserver. We can see that currently this particular script has launched a server application on this virtual machine. We can also verify that this process has been started by typing processes-ef grep netserver. And we can see that this process has been started with the process ID 6372. So let's leave this virtual machine untouched. Now let's go back to our Linux 01 VM. Now we are going to launch the client application on this VM. So let's change our directory, our working directory, to root/netperf also. And now we need to launch a client application, which is ./nptest1.sh, and after a spacebar we need to type the IP address of our Linux 02 VM as our server. So let's verify its IP address again. Config. It's 172.20.10.200. So let's type it here, 172.20.10.200, and let's type enter. And now our client application has been started successfully. So what are we going to do next? Let's return to our multi-party session to our ES6i host 04. And now let's locate the VM NIC number 2 here. This is the physical network adapter of our ES6i 04 host, which is used by a PG production port group of our DVS lab, DVS in our particular lab environment. One of our VMs, Linux 01, is connected to a PGSA production, and this particular port group is currently using a VM NIC 2 as its uplink on ES6i 04. So what we can see here, we can see the level of megabits transmitted per second and megabits received per second by this particular VM NIC. So we can see the number somewhere around 100 megabits transmitted per second by this particular uplink, and the level of 1 megabit received per second by the same VM NIC. So let's record those values. Let me open my prepared text document. Let's go to our different port groups section. So this is our first test in this lab. So let me record the values. The first value for megabits transmitted per second is somewhere near 100 megabits. And our level of megabits received per second is somewhere near 1 megabit per second. So, what are we going to do next? Now we are going to simulate some level of network congestion between our VMs. For doing that, I'm going to configure a traffic shaping policy and apply it to my PGSA production port group. So how we can do it? Let's go to our vSphere client. Let's go to our menu networking section. Let's find our PGSA production port group. Let's right click on it and let's choose the edit settings option. Now, on the left side of this edit settings page, let's click on traffic shaping. Now I'm going to enable the traffic shaping policy in both directions for this particular port group, for ingress and egress directions. I'm going to enable my ingress policy. I'm going to limit it to 10,000 kilobits per second on average, 10,000 on peak bandwidth kilobits per second on average, and 10,000 of burst size. And I'm also going to enable it in egress direction. Again, I need somewhere around 10,000 on average bandwidth, 10,000 on peak bandwidth, and 10,000 for burst size, for a burst size. Let's click OK. So let's see that our PGSA production configuration was changed and it's completed. Now, let's go back to our ESX top output. And now we can see that the level of megabits transmitted per second is significantly lower than during our first test, our previous test. So let us record those values. So during this simulated network congestion, we can see that our previous value of near 100 megabits per second has been lowered to a level of near 10 megabits per second, as we configured in our traffic shaping policy. So let's record this value. So somewhere around 10 megabits for transmitted And again, somewhere near even lower. Here we can see that the megabits received per second is also lower. So let's type 0.15. Next, what we are going to do next right now, we are going to disable our traffic shaping policy. So let's go back to our vSphere client. Let's right click on our PGSA production. Let's click on edit settings. Let's go to a traffic shaping configuration and let's disable it for both directions. Again, don't forget to disable both of those configurations. Let's click on OK. We can also return to our ES6 top output, and we can see that these numbers are actually growing up right now. So our previous value was 8 megabits, then it became 50, and now it's again somewhere around 100 megabits per second. And our megabits received per second has also returned to its previous value, somewhere near 1 megabit received per second. So what we are going to do next? Now we are going to migrate our VMs to a single port group. We are going to connect both of our VMs to a PGSA production network. For doing this, we need to go back to our Linux 01 VM. Let's stop this test by typing Ctrl and C. Now, let's go to our Linux 02 VM. Again, let's verify the process ID of the net server application. It's 6372. Let's stop this process by typing kill and the process ID 6372. Now it has been stopped. What we are going to do next? We are going to reconnect our Linux 02 VM to our PGSA production network, where our Linux 01 VM is located. For us to do it, we need to go back to our vSphere client. Let's right click on PGSA management port group in our networking section. Let's choose migrate VMs to another network option. Our source network for this migration is PGSA management, and our destination network is going to be PGSA production on our DVS lab. Let's click OK. Let's click next. Let's choose our Linux 02 VM here. So we are going to connect it to our PGSA production port group. Let's click on next. Let's verify that we are going to migrate one VM from PGSA management port group to a PGSA production port group. Let's click on finish. Let's look that our Linux 02 network reconfiguration has been completed. So let's go back to our Linux 02 VM. Let's restart its network settings for this VM to be able to receive another IP address in different network environment. So let's type service network restart. Let's wait a bit. Let's verify our new IP address by typing ifconfig. Now it's 172.20.11.201. Our Linux 01 VM has the IP address of 172.20.11.200. So now both our VMs are located in a single similar subnet, in the same subnet, are connected to the same subnet. So now let's repeat our steps by starting a server and a client applications. So let's do it. On our Linux 02 VM, we need to start back our network server application. So let's go to our Linux 02 VM. Let's type a net server command. Net server. Let's start this script. Again, it has been started in the background. Let's again remember our IP address for Linux 02 VM 172.20.11.201. And on our Linux 01 VM, let's start a client part of this application by typing /nptest1.sh and our server IP address 172.20.11.201. So let's go back to our ESX top utility. And now we are going to find the additional information for our virtual machines. So let's find our Linux 01 Ethernet 0 network adapter. And let's verify its value. We are not going to watch the VMNIC2 statistics anymore because currently this adapter is not applicable here. Our traffic between both of our VMs is now traversing the only port group, the PG-SA production, and it stays inside the virtual switch, the distributed virtual switch on the particular ESXi host. So our uplink adapter, our physical network adapter, currently is not needed for those packets to traverse between both of our VMs. So now we can see directly to our Linux 01 Ethernet 0 network adapter, and let's record the values we can see here right now for our megabits transmitted per second and our megabits received per second. So let's record those values. Again, for the same port group, in my case, the megabits transmitted per second is on average somewhere near 320, and for our megabits received per second, the value is somewhere around 2 megabits per second. So here we can see that the largest amount of network performance our VMs, our Linux 01 and Linux 02 VMs, achieve when they are connected to the same port group being located on the same ESXi host, our ESXi 04 ESXi host. So that's because our virtual machines do not need to use the physical network adapter of the particular host to communicate between each other. And now they can communicate directly between each other using just the single port group and of a single DVS between them. So now we can see the result of those migrations and placing our virtual machines on the same physical host in the same port group. So our lab is completed. Congratulations, you have completed the Monitoring Network Performance Lab demonstration video. During this lab, we have prepared our environment of client and server VMs to run network tests. We have seen how we can measure network activity on an ESXi physical network interface. What do we need to do to use traffic shaping to simulate network congestion? And finally, we have reconnected one of our VMs to measure network activity in a different set of circumstances when two of our VMs were connected to the same port group. Thank you for watching this lab demonstration video. I hope the knowledge acquired here will help you with your daily job assignments, and good luck as you continue your journey in VMware world.